Okay, let's try the first problem. You might want to write, Robert, you might want to write the formula on the top of your paper, just as a reminder. So we're doing, now, I must warn you, because in a couple of days or tomorrow, there is a word that's very similar to molarity. It's called molality. And the only difference is that R is an L. So you really need to pay attention to the spelling of the word, because the calculation is different. This one we use most often, but probably what you should do is maybe write the formula on the side. Molarity, which is represented by a large M, is the moles of solute over a liter of solution. I usually write it like that. Some people just put an L. You can just put an L if you want to. You know how I am. Okay, let's look at the first problem. We have 2.3 moles of sodium chloride, and the solution is only 0.45 liters. It says an L, and it says SOL with the apostrophe N. You can just put an L if you want to. I just put liter solution because I was taught like that a long time ago. You know, I'm kind of, don't like change solution. So easily. So you can just put an L.
Is it like Southern? Like
I don't think so.
No?
No. No.
Yeah.
You know, and I think it's old is what it is, because I think Miss Corsini does it too. But if you go to college, they're just going to put an L down there, and they go, why bother? You know, I'm just hard to change certain things. You know, kind of stuck in the old way. Yeah, I'm kind of like that. You know, I am. All right. Now let's look at the first one. We have 2.3 moles of NaCl, and the solution is not a liter. It's only 0.45 liters. So really this is only division to get the number over 1. So you just divide 2.3 by 0.45, and you get 5.1 moles over liter. And then if you were to write that probably on a container or something, you would just write this. That would be your answer.
Is that it?
That's it. Isn't that nice? Okay, should we try just one more and I'll let you do the rest?
You just divide?
All right. So you would do the exact same process for 2, 3, 4, 5. But number 6 is a little different. How is it different? There you go. All you have to do is convert how many grams you have to the number of moles you have, which means you have to know how to write the chemical formula. So, how do you write calcium nitrate? I'm sorry, it's not nitrate, it's nitrite. Excellent. So now we need to know what the molar mass. So you need to figure out the molar mass. And just so as a way of not wasting time, I'll tell you what the molar mass is. The molar mass is 132.1 grams. So now you can convert that 120 to how many moles you have. So you have more than a mole or less than a mole? Less. Less. Okay, so 120 grams times 1 mole. Well, you know, she was thinking on her own time, right? It's 132.1 grams. And so I ended up working this problem out earlier, and I got 0.91 moles. And that makes sense because if 132 is 1 mole, and we have 20 grams, we have a little less than a mole, so 0.91 makes sense. But we don't have a liter solution, do we? We have 240 milliliters. So how many liters is that? Yeah, 0.24. 0.24 liters. And so then it's simple division again. And I ended up getting 3.8 moles per liter. So you would write on a container 3.8 m, and then you'd write the name of the salt. or you could write the chemical formula for the salt. But the only difference with problem 1 and problem 6 is in problem 1 the mole value is given to you, so that's nice. But in problem 6 through 9 you have to convert to moles, which means you have to know how to write the chemical formula. So how do we write sodium hydroxide in number 7? Because that's what's going to get you. That's what's going to mess you up if you forgot how to write the NaOH. All right, good. What about hydrochloric acid? Perfect. And what about ammonia? Right, NH3. Oftentimes people get ammonia and ammonium confused. But remember, ammonium is the positive polyatomic ion, NH4 with a plus. Ammonia is just NH3. So do you think you can handle those problems?
Yeah.
And turn them in tomorrow?
Yep.
That's a beautiful thing.